Okay, guys. Today we're going to talk about dilations on the coordinate plane. Um, some key points that I want to make on here is that dilations, when you perform a dilation, the shape should be the same. Okay. And I'm going to put a term here, similar. You might hear the little one in the background, just kind of ignore her. The other thing about dilations is the shape could either stretch, which means to get bigger, or shrink. Okay. This depends on the scale factor that is used. So I want to write that down here. Depends on the scale factor. All right. Uh, let's talk about the scale factor that they're going to give you or could give you. If the scale factor, focus on the top right of your screen here. If the scale factor is greater than 1, it's going to get bigger. The shape should appear bigger. It's going to be a stretch. Okay. Now, if the scale factor is less than 1, it's obviously going to shrink. Clearly, it should shrink. Okay. We're going to take a look at an example, and what do you do with the scale factor? Like I said, all this time, it's all about moving the points. Okay, we're going to focus on the points. So let's explore this problem here. Right here we have a pentagon, and I already have the points labeled A, B, C, D, E. And what we're going to do is we're going to dilate this pentagon with the center at the origin. Now, guys, most of these dilations will be a dilation with the center at the origin. Okay, will it always be that? No. In most cases, it is. And then they're going to give us a scale factor of 1/3. Well, if we go back in a scale factor, if it's less than 1, it should shrink. It should get smaller. Okay? So our scale factor here is 1/3. That's clearly less than 1. So we're going to see this pentagon shrink up a little bit. Now, all you have to do is manipulate these points. Let's look at point A here real quick. All right, here's my X and here's my Y. And each coordinate that I'm given, I'm going to times by my scale factor. Okay, and we'll switch colors here. Let's go green. So if I take 0 times it by 1/3, well, it gave me 0. If I do the same thing with my Y coordinate, I'm going to times that by 1/3 again. I'm scribbling here. And I get 0 again. Now, this is kind of normal, so don't fret about it. I'm going to plot that point, okay? Even though it didn't change, right there's my A prime point, okay? That's just part of the dilation. With the scale factor, guys, all you got to do is multiply your scale factor by each coordinate, the X and Y separately. All right, let's look at B. If I look at B, my X and my Y are both 3. Okay? So if I take this x-coordinate from point B and I times that by 1/3, 3 times 1/3 is 1. Okay, so there's my new x-coordinate. I'm over at the top left of your screen now. Of course, I could bring it down here too. Now, what would my y-coordinate be? Well, I'm going to take my y-coordinate and times it by 1/3, and I get 1 as well. So, I already got my second point. So, I'm going to go ahead and plot it. Here is B prime. 1, 1. Crawl before you climb. Okay. Now, let's just keep going. All right. If I'm going to dilate C, let's look at its x-coordinate. 6. If I take 6 times 1/3, that gives me 2. All right. Do the same thing with the y-coordinate. 3 times 1/3 gives me 1. So, obviously, I'm going to plot that point 2, 1, and that's my C prime point. All right, let's just keep going. Guys, be careful with signs too. Okay, you might want to say it to yourself. Okay, I got 3 times 1/3, which is 1. We've already done that. But now I got -3. Okay, that negative plays a factor in this. -3 times 1/3 is -1. So now I got a point in the fourth quadrant, my D prime, and it is right there. All right. And E prime, I'm getting really sloppy with this thing. I'm going to take my x coordinate, 6. I'm up in here somewhere. Times 1/3, that gives me 2. Do the same thing with my y coordinate. -3 times 1/3 is -1. And I have my fifth point. Guys, in dilations and all these transformations we've talked about, you got to focus on the points. Okay, you can't predict. Some could, some say they could, but it is definitely hard to predict where something's going to end up. Okay, that's why I like to focus on the vertices. All right, now what I'm going to do is kind of give you a roundabout thing here. There's that example there. There's all of our points. Okay, I just got online here. Now this example here, this shows you a dilation where the center is not the origin. Okay, they're letting point E be the center. Now if they let a point on the figure be the center, you don't need to move it. All right. And with the scale factor of 1/2, obviously, go through the motions here. The thing about with the center being a point and a shape like this, if you look at side EF, I'm looking at the pink purplish rectangle. The length of it is 1, 2, 3, 4, 5, 6. Well, if the scale factor is half of that, I need to make my new length only 3. Look at the blue rectangle, E prime to F prime, 1, 2, 3. So I don't even really need to multiply anything. I just need to fixate this point here and count the length of the sides. Now along this coordinate plane, it's easy to do to find that length. This is one where you would not want to multiply the coordinates by the scale factor. If we look at EH from this point here to here, we have 1, 2, 3, 4. What's half of that length? 2. So from that point, I'm just going to count over 2 spaces, and there's my H prime. Okay? Alright, guys. I'll see you later.